All right, this video is to go over the Unit 7 review, page 2, or in this case, page 26. I'm just going to work through each one individually. So if I start with the top one, we are still simplifying. So if I ask you who has more A's, I would have more A's on the bottom. 7 minus 2 gives me 5 left over on the bottom. And remember, your placeholder up here has to be a 1. We do not have to rationalize this because that 5 is a whole number. If it was like a 1/5, then we would rationalize, okay? But that is your final answer. All right, looking at M. First thing I notice is that I can take the 4th root of 81. If you ever forget, break 81 into 9 times 9, and then 3 times 3, 3 times 3. So the 4th root of 81 is 3. Now, negative exponents. These do not make the numbers negative. All it does is change your level. So this is the exact same thing as saying 1 over 3 squared, okay? And 3 squared we know is 9. So my final answer looks like this. If you went the opposite way and kind of did the negative first, you could have rewritten it as this. And then done this option and over, okay? Either way works for me. All right, N is going to be a rationalized, and I'll show you how I know that. When I break this apart, I'm going to get the 4th root of 5 over the 4th root of 2. There's nothing I can do with either one of those, and I couldn't divide 5 over 2. So talking through this the same way we did before, this is like saying I have 1 2, I need 4 2. So I want to multiply by what I want. I want 3 more 2's. Okay, whatever I multiply on the bottom, I have to do on the top. I like to expand that out. So 2 to the 3rd power is 8, and that helps me multiply across. Okay, so now on the bottom, I have the 4th root of 2 to the 4th power. Across the top, since 8 and 5 both have the same radical, I can say the 4th root of 40. And then 2, 4th power and a 4th radical means that they cancel out. I get the whole number of 2. So this would be your final answer. Okay. All right, that's the top box. Let's move into the bottom. The bottom is saying evaluate. Evaluate means there are no variables. I need a final number answer. Okay. So you can use radicals, you can use fractional exponents, whatever makes the most sense to you. For me, radicals are easier. So if I look at this, I say the cube root of 64. I'm going to make the number smaller before I square it. I'm not going to square 64 and then try to cube root that number, okay? All right, 64 is like 4 times 16, and then 4 times 4. So the cube root is 4, and then square it gives me 16. This is my final answer. Okay, if I look at this one, negative 5. I'm going to do the same thing, cube root of 216, and then square it. Cube root of 216 is a 6, so I have 6 squared. Oops, I changed that to a 5, sorry. All right, that means I have negative 5 times 36, and that gives me negative 180. Again, you could multiply that out without a calculator. All right, C. So I'm going the 5th root of a negative 32, and I'm going to raise that whole thing to a negative 3rd power. Okay, so I kept the negative with the top number. All right, looking at that, 5th root of a negative 32 would be a negative 2, and I'm raising it to a negative 3rd power. Negative 3rd power means I'm going to change its level, so that's the same as saying negative 2 to the 3rd power in the denominator. Anything negative, if you raise it to an odd power, stays negative. So that's like saying negative 2 times negative 2. That's going to give me 1 over a negative 8. Final answer. All right, last one. For me, since I see this negative, it's easier for me to flip this. So I'm going to put 512 on top, and I don't really need the over 1. I'm just going to leave it as 512. I'm going to cube root that, and I'm going to make it smaller before I square it. Cube root of 512 is going to be 8. Again, this is on the list of ones you're supposed to memorize. And then 8 squared gives me 64. This is your final answer. Moving to the next row. simplify the expression. Simplify, again, if you start with fraction exponents, you have to end with fractional exponents. If you start with radicals, you have to end with radicals, so keep that in mind. All right, when I'm trying to simplify rational exponents, I have to get the same common denominator. So if I have a 4 and a 5, my common denominator is going to be a 20. So I'm going to keep my k's, change them to a 20, and then if I think about going this direction, I need to make sure that if I do 4 times 5, that I do the same thing on the top. So that makes 15. 5 times 4 to get this one, 2 times 4 would give me 8. Now I can add up my exponents. So if I say how many total k's do I have? Still keeping the 20, but 15 plus 8 makes 23. It doesn't look like that's simplified, but it is the final answer. Let's look at F. Okay, for F, I'm going to check in the parentheses. Is there anything to simplify? No. I'm going to go ahead and distribute my exponents. Okay, so I'm going to distribute to him, distribute to him, distribute to him. That gives me b to the negative 2 over 32 to the negative 2/5. And if you wanted to write that as a radical right there, that's fine. And then it gives me a to the 4th, and that's just multiplication. All right, couple things we're going to redo. Negative exponent moves down, negative exponent moves up. When I rewrite this, I am going to make it a radical now. 5th root of 32, I'm going to make it smaller before I square it. The a was on bottom the whole time, and the b moved to the bottom. Now, 5th root of 32 is 2. And then 2 squared gives me 4. So if you could do that all in one step, that's fine, but this is the final answer. All right, let's go to G. G kind of looks like you're supposed to combine, but because these are not like terms, like if they were both 3 over 2 or both 5 over 2, you'd be fine, but I can't combine them. That's like saying x squared minus x to the 3rd. I can't put that together. What I can do is distribute. And remember, when you distribute, we are multiplying. Multiply, there we go. So we add the exponents. All right, so if I'm thinking 1/2 plus 3/2 makes 4/2, that's this one. And then if I go this way, I'm saying 1/2 plus 5/2 makes 6/2. So again, simplify those fractions. 4 over 2 is 2. 3 over 2 is 3. It looks like you should be able to combine, but you cannot. That's a final answer. All right, going to H. Since these are the same, you can put them together first, or you can put them together second. I'm going to show you what I would do. For me, visually, I am probably going to rewrite them as radicals first. And again, this is just my personal preference. I'm probably going to write them like this first, and then put it together since the pieces match. So since this is all the same, I can do one big cube root and one big square and put those fractions together, 250 over 2. Because if I write it like that, now I can simplify that into something that actually helps me. So I would say cube root of 125 and then square it. Well, 125 is a number I'm supposed to know as a cube. That gives me just 5. And 5 squared makes my life a lot easier. Your whole goal is to try and use numbers that make your life easier. Okay. All right, let's go down to I. So I is one of those where we're trying to add the exponents. So for me, I kind of ignore the a's to start, honestly, and I worry about focusing on square root of 72 plus square root of 50. Okay? Square root of 72 is like saying 8 times 9, and then I got 2 times 4, 3 times 3, and 2 times 2. So I have a set of, I have a set of 2's and a set of 3's. That would look like 6 square root 2. Okay, if you knew that a 36 was in there, that's awesome. This is in case you didn't. To do a 50, I would do 2 times 25, and then 5 times 5, so a set of 2 goes on the outside. So plus 5 square root 2, and the 2's that are on the inside are these guys, because all of this got broken, okay? All right, so now if I focus on that, 5 root 2 and 6 root 2 would add together to make 11 root 2. And that is the exponent I'm going to put on my a. So if I add those two together, I get a to the 11 root 2. All right, there is a lot going on j. I'm going to show you how to make your life easier before you make it harder. Okay, first of all, simplify these guys. Simplify your x's, simplify your y's before you start distributing the exponents. Okay, so if I do that, in blue, 5 halves minus 1 half makes 4 halves, right? 4 halves is 2 whole. Same thing with the y's. 1y minus 1y is gone. Okay, they canceled. So this is a lot easier to work with than what we had before. If I move down, I'm going to use radicals. Again, makes my life a little easier. I'm going to do cube root of 8x squared. Notice that I put the 8x squared all together. Same thing on the bottom. I'm going to do the cube root of 27. I'm doing that because 8 and 27 are both perfect cubes. So if I pull an 8 out, that gives me 2 whole. Keeping it cube root of x squared, and cube root of 27 is 3. Now, the problem is that I started with fractional exponents, so I have to end with fractional exponents. Your answer is not done until you get to here. Okay? You have to keep the same kind of answer. Last one in this section is going to be k. Again, I'm going to rewrite them straight into fractional exponents. These guys are positive, so I'm going to keep them on the top. So x to the 2/3. This guy, though, he's negative. I'm going to go straight to the bottom with him. X to the 1/4. Now, they have to have the same denominator in order to work with this. So if I'm trying to make same denominator, I'm going to rewrite that with a denominator of 12. So multiplying by 4 here would give me 8. Multiplying by 3 here would give me 3. And now I can cancel that. If I have the same bases right here, whoops, sorry. If I have the same bases of x's here, I can say who has more x's? The top. How many more x's does he have? 5 out of 12. There's nothing on bottom, so that's like a whole number. Your answer could be left like that. You don't even need the over 1. Your answer could be left like this, or the 12th root of x to the 5th. You could do either one because you had both to start with, radicals and rationals. Okay? All right, we are going to do 2 quick problems on the bottom. The directions do not say check for extraneous, so you don't have to do that. All right, here's how I would solve this guy. I would get in the habit of showing your work because you're going to be expected to do it on a test or a retest. So I'm subtracting 350 from both sides. That gives me negative 720. Divide out the 3. Oops, sorry, 729. 5th root of a negative 243. Now, when I take this and I take a 5th root of it, you are allowed to take an odd root of a negative number. So the 5th root of 243 is 3, but you have to make sure that your answer is going to come out to be a negative 3. Okay? All right, any questions on that one? Perfect. B is where most of the problems are going to happen. A lot of people in the quiz only gave one answer. So let me show you what I mean by that. 4th root means I need to take, 4th exponent means I need to take a 4th root. If your root is even, that means you have to have a plus or minus when you apply it. That's why it's important to draw that. That way you know when to put the plus or minus. So these cancel, and I have x plus 4 equals. The 4th root of 625 is 5, but it's plus or minus 5. I like to break this into 2 problems right here. I like to say x plus 4 could be a positive 5 or x plus 4 could be a negative 5. That way I make sure I solve for both. If I subtract 4 from everybody, I now get 2 answers. I have a 1 and I also have a negative 9. If this was a quiz or test, you'd want to check for extraneous, make sure both of those work. I'm going to tell you that they both do, but this point of this question was to make sure you ended up with 2 answers. Okay? That is the end of our second video. I will make one more video for the last pieces.